Trigonometric equations, also known as solving for the general solution. So the first example I'm going to talk about, one of our teachers looked at this and said, let's look at common examples, which they call type 1 equations. And I'm going to give you an example like that. Tan of 2x plus 30 degrees is equal to negative 3. Okay, so the form of this is that we have a trigonometric ratio, which we call the function. That's our ratio, or the function, right? The trigonometric ratio, or function. This we consider a given angle. That's your angle. And some number, which is a constant, right? Okay. Now, when solving these questions, we tend to ignore the minus sign. And I'll tell you when we look at them a little bit later. So there's a method that is used for this. It is called the Qrs method. Q for identifying the quadrant, R for determining the reference angle. Okay, in other words, it's the value of this angle over here. And then S for solving, right, for actually solving the trigonometric equation, solving the equation. So we're going to follow those exact steps. Now, when we look at this, we need to firstly say that, well, I've been given a trigonometric function, I've been given tan of 2x plus 30. I can now identify that I've got it equal to negative 3. And so now you ask yourself, where is tan negative? Where does it result in a negative value? And well, tan is negative in the second quadrant and the fourth quadrant, because the first and the third identifies tan as positive. So I'm going to say in terms of Q that I'm working with the second and the fourth quadrant, right? And that's where we're going to solve the general solution for. Then we need to determine the reference angle, which is R. And how do we do that? Well, we simply say 2x plus 30, in other words, this given angle, is equal to second function of tan, right, of negative 3. Now, when we deal with this on the calculator, what we do is we ignore the negative. So we just need to put in positive 3. We don't need to use the negative, because the negative only indicates which quadrants we are working with. And the important thing there is that's what I'm going to show you in a moment, right? Okay, so let's just enlarge this a little bit and see what we're going to be pressing on the calculator, right? So we're going to go second function. If you're using the 82ZA+, you're going to press the shift button. You're going to then press tan, and then once you press shift and the tan button, you get tan to the minus 1. Okay, and then you're going to put the parameter or the argument or the input in, and that's going to be positive 3. And then you're going to get a result of 71. Angles you can round off to 1 or 2 decimal places. And I'm going to say, therefore, 2x plus 30 is equal to 71,6 degrees. Right. Okay, and so that solves what we call the reference angle. Now, a common error that many students make is they go further and they solve for x here. Do not solve for x here. Use the angle as 2x plus 30, the given angle, right? Use that. Okay, and now we use solve. Now we're going to solve. So let's do the third step. Now, when we solve, we identify the quadrants, and remember we're going to be working in the second quadrant, which I'm going to label over there, and we're going to be working in the fourth quadrant. So for the second quadrant, we take the given angle and we make it equivalent, so 2x plus 30 degrees is equal to the reduction formula, right, for that quadrant. So in the second quadrant, you are well aware, so this can go smaller again because I've already got 71,56, as you can see. I've covered that part now, right? So you know in the second quadrant, it's 180 minus theta. So I'm going to put in there 180. Theta is now the reference angle. So we say 180 minus 71.6 degrees, right? And then you need to look at what type of function I'm working with. And the function I'm working with here is a tan function. So in the tan function, we say plus n multiplied by 180 degrees because the tan alternates and it repeats itself every 180 degrees. So whichever angle works now, that's going to work for this as well. Okay, and you can stipulate that n must be an element of the integers, right? So now you can actually go ahead and solve for solve for x, right? Take the 30 over, or subtract 30 from both sides. It's going to be 150 minus 71.56, which is 180 minus 30 minus 71.6. That's going to give you 78.4 degrees, right? Plus n times 180 degrees, right? And now that's the value of 2x. Now we need to solve for x. So when we solve for x, we divide both sides by 2, right? And therefore the equivalent here is going to be, x is going to equal to 39 degrees, comma 2, right? Sorry, because I'm dividing by 2, 39.2 degrees plus n multiplied by 90 degrees, okay, such that n is an element of the integers. And there we've solved it for the second quadrant. Now I still need to do a solution for the fourth quadrant, and that's what I'm going to show you on the next page, right? So for the fourth quadrant solution, we say, well, the angle that was given is 2x plus 30 degrees is equal to 360 degrees, this is the reduction formula, minus the reference angle that was given, which is 71,6 degrees, plus n times 180. Now it's 180 because I'm dealing with tan. Okay, so now we can go and we can simplify this. 330 minus 71.6, and that's going to give me 258,4 degrees plus n times 180. And I still have 2x on this side because I've gotten rid of that. So now I can divide everything by 2. And as you can clearly see over here, I'm going to have n times 90 degrees. And 258 divided by 2 is going to give you 129,2 degrees. Right, plus n times 90. Okay. And that's the value of x. And so we have now found the general solution. So don't worry, we're going to do at least another 9 or 10 examples of this. That will make things easier. Okay.